Hi all, so in this particular video we'll look into the basics of the linear motions that we have already seen in the beforehand stage. Okay, so sometimes it is also referred as a rectilinear motions, right? So we'll start with the basic definition of what do you mean by distance as well as displacement, right? So distance, let me just consider 2 points, point number 1 and point number 2 over here. Your displacement is referred as the shortest distance between your point 1 and 2, right? And most importantly, displacement will be always a straight line. Your distance, on the other hand, depends upon the path. So this is what is given over here. Okay, so your displacement and distance are entirely different from each other. Displacement is the shortest distance that is present between 2 points, and it is always going to be a straight line, whereas your distance depends on distance depends upon the path that is taken by the object to travel, right? Next is your speed and your velocity, right? So when we talk about the term speed, there's another terminology that comes along with it, which is velocity. Okay, so what is the difference between the term speed and velocity? Your speed has a magnitude only, whereas your velocity, on the other hand, has a magnitude and it also has a direction. Okay, so if one term has both a magnitude and direction, it is of course referred as a vector quantity, whereas your speed has magnitude only, so it is a scalar quantity. So this is the difference between your velocity as well as your speed. So we have two other terminologies when it comes for speed. This also carries over for your velocity definitions also. Instantaneous speed. Okay, so let me say at time is equal to 2 seconds, we are going to have a speed 2, and when time is equal to 10 seconds, we are going to have another speed. Let me just tell it as speed 10. So at each and every time step, we are going to have a different value of speed. Sometimes it may be same, but we are going to have a different value of speed. That is referred as instantaneous speed. At any given instant and any given time, we are going to have a value of speed. That is referred as instantaneous speed. Whereas the average speed is basically your distance traveled divided by the time of travel. Okay, so if you go to the previous point, you will be able to understand your distance is actually the path traveled. So the definition is the path traveled divided by time taken for traveling that particular path. Okay. Next is velocity. Here again I have told you what is the definition of velocity and speed, or what is the difference between your speed and velocity. So velocity is a vector quantity, and average velocity is basically change in position divided by time, or displacement divided by time. Here again displacement, recall it, it is basically your shortest distance between 2 points. Okay, let me just put it over here. Your displacement is your shortest distance between 2 points divided by the time that is taken to travel that particular distance. Okay, so here this particular graph will tell you or shows basically how your velocity of the object is changing. Just look only into the blue color car that is traveling. So it starts from this particular position 20 meters. Okay, so it starts from this 20 meters, time is 0, and when it is moving, you will be able to find it is moving with a constant velocity. Its velocity is not let me say increasing, not decreasing. Whereas the red color car, if you look into it, it starts from the 0th position. Okay, so that is the reason why you're having this 0th position start over here, but obviously it is moving with a higher velocity, right? Let me go to a static graph that will give you a better understanding. So just consider this particular graph 1 and this particular graph 2. So this is where this particular line has a slope. Let me just call that particular slope as theta 1. This particular line has another slope, we are going to call it as theta 2. So if you compare 1 and 2, theta 2 is higher than theta 1, which will tell you if your slope is higher, it signifies your velocity is also on the higher side. If your slope is lower, then it also signifies your velocity is on the lower side. Okay, so if you compare graph number 3 and graph number 4, the only difference is both these graphs will have a negative slope. Apart from that, the same terminology will carry. Here we have theta 3 and here we have theta 4. Obviously, theta 3 is less than theta 4, or theta 4 is higher than theta 3. So which means this particular graph or this particular object has a higher velocity and this one has a lower velocity. So please take this as a thumb rule. If you have a higher slope, you are going to have a higher velocity. If you have a lower slope, you are going to have a lower velocity. The last one is your acceleration. Acceleration, very simple, change in velocity divided by time. So here terminology u corresponds to the initial velocity and v term corresponds to the final velocity. So here again we have 2 points. This is just for example. So point 1 is where we are going to start and point 2 is where we are going to end. So let me say it is going to move in a straight line. Starting point has a velocity which is u, and this is the ending point or the final point which is going to have a velocity v, and the acceleration is your final velocity divided by initial velocity divided by the time taken to reach from point 1 till point 2. Okay, so here again there is another graph which will tell you on a much clearer basis. This particular color green refers to B, this refers to C, and this refers to A. Okay, so this car, if you look into it, is moving with a linear velocity. So your position is changing on a linear direction, whereas point C is slow on the initial side, but as it moves, it picks up the speed and then it reaches a saturation point. Whereas red color point, which is your A, starts with a higher velocity, but soon it reaches a saturation point, which means the change in velocity, the change in position is not on the higher side. So here again you can look into it. This particular green color car is moving with a bit of higher, or let me say the change in position is uniform. You have a linear scale. Whereas this particular blue color car is starting slowly but increases the pace of its motion. And this particular red color car initially moves faster but gradually reaches a saturation point. Right. So these are the general thumb rule, but the most important takeout point over here is if your object is slowing down, it is termed as negative acceleration, or it is also called as deacceleration. So if this particular concept is appearing, obviously your acceleration will be taken with a negative sign. Okay, and if it is moving or speeding, depending upon that also your acceleration is prone to change. So this particular GIF file will tell you how your velocity and your acceleration is present. So when it is sliding down, when the ball is sliding down, you will be able to find that your velocity is basically starting from a lower side and then it reaches a constant value. Similar is the case with the acceleration. And when it is moving in this particular linear direction, just a second, in this particular direction, you can find that the acceleration changes its sign. Okay, so please look into this figure for a better understanding of how your acceleration is behaving. So with this, we'll get into the, or we'll finish off this slide, which will have all the basics required to deal with the problems. Thank you.